Today, we're having a look at lesson 47, which is finding the percent of increase or decrease of a number. This is not a new skill, all right? This is not a new skill. It's something that is you've done in previous courses. And so we'll be able to blow through this pretty quickly, I think, and get to where we want to be. Now, somebody give me an example in real life of a percent of increase.
Taxes.
Taxes, that's right. If you add tax to an item, then that is a percent of increase. The increased amount is a percentage of the original amount. All right? Now, what about an example of a decrease?
Like 20% off or something like that.
20% off is a discount, right? Salary, explain.
You ask for a raise and then he hires you.
That's not a decrease. So there are decreases. We pay a tax out of our salary. So there's deductions that are percentages of your salary on a regular basis. So that would be a percent of decrease as well. So you guys are used to doing that. Right? So you're used to thinking about a percent of increase, percent of decrease. The key word, and I've said it several times with emphasis, is that the percent of increase or the percent of decrease, what's the key word there? Of. It's always a percentage of something. And what does of tell us in mathematics? It tells us that we're going to be multiplying. All right, so the percent of increase or percent of decrease is always going to be a percentage of the original amount. And to find a percentage of something, we're going to multiply the percent over 100 times whatever the amount is. So I kind of want you to kind of get used to that. Percents cannot stand alone. It's always a percent of something or part of something. Okay? All right, so first of all, let's kind of have a look at the percent of change. All right, this is a definition. And there's a formula that goes with this definition, so it's going to be very important to know it. The percent of change is the ratio of the amount of change to the original amount expressed as a percent. All right, percent of change is the ratio of the amount of change to the original amount expressed as a percent. You did this in pre-algebra also. Percent of change. This is not a difficult process. You just have to remember what it is. All right, key words. What are the key words in this definition? Ratio. What is ratio? It is a comparison of two numbers by division. So it's the expression of two numbers in fraction form. The ratio of 2 to 5 is 2/5. Okay, so it's a fractional expression. So this is telling us that the percent of change is the ratio of the amount of change. So the formula is the amount of change divided by the original amount. All right. And to change it to a percent, multiply it by 100. So the percent of change is the amount of change divided by the original amount times 100. This is a very easy process, if you will choose to memorize this formula. If you don't choose to memorize this formula, then you're going to be kind of squirreling around on the test, squirreling around and missing some really easy problems that you don't need to miss. The percent of change is the amount of change divided by the original amount times 100. Okay? Any questions there? All right, the percent of change can be a percent of increase or a percent of decrease. And I'm going to want you to be specific. All right? It's not specific enough to say it changed by 25%. You need to say it's a 25% increase or it's a 25% decrease. All right, so the percent of change, always you need to be specific about whether it was a percentage of increase or a percentage of decrease. All right, so let's look at a couple of quick examples of that. Find the percent of change is the directions here. It says the number of U.S. airports in 1985 was 15,161. The number of U.S. airports in 2005, 19,854. So find the percent of change. Excuse me for yawning on you there. So what is the percent of change? What's the formula? It's the amount of change over the original amount times 100. So the amount of change is going to be the change between these two numbers, right? So the amount of change is going to be 19,854 minus 15,161 divided by the original amount. Now, how can you tell which one is the original amount?
The one that came first.
So which one's the original amount, Jay?
The number of U.S. airports in 1985.
Which is
15,000.
15,161. Pay attention, bub. 15,161. So we've got the amount of change, and then we got to multiply it by 100 to get it into percent form. All right, now it'd be nice if you had a calculator handy. That's going to be 4,000. Who's got a calculator handy that can punch this in? All right, go ahead, Josh. 4,693 divided by 15,161 is what? All right, 0.309, so that's going to be 30.95. All right, we'll just leave it right there. 30.95%. Now, let me ask you a question. When did airports start? Or when did airports originate? When did we first have airports in our country?
Sometime after
After World War. Yeah, I mean, as far as, if y'all will listen, all right, the Wright brothers was 1912, but by 19, World War I was late teens, right? We had some pretty sophisticated air warfare in World War I. So it really, really, really expanded, right? This airplane, flight, traveling by air really escalated quickly. If you think about it, 1902, the Wright brothers, was that when it was?
1912, 1902.
Yeah.
All right, somebody else said that.
I don't know.
I don't remember.
1950.
I'm thinking it was, I don't remember. I figured you guys would know. Early 1900s. But within 10 years, we're fighting air battles in World War II. And then there's air travel by the 1920s, 1930s. People started flying by air. And if you look at the airplanes in World War I compared to the airplanes in World War II, 30 years later, there's light years distance between those things. Right? In World War II, we're dropping atomic bombs out of long-range bombers. 30 years after World War I, where they're flying biplanes. Right? So the explosion of airfare, of air travel and airports was huge. But does this seem like a big number or a small number?
It's pretty big.
That's a pretty big number, right? For something to increase this late in the game. By the 80s, everybody's flying. And what happened in 2005, 2006, 2007? Y'all don't really remember that much because y'all were kids. 2005, 2006, 2007, we had this huge economic crisis. Ask your parents, especially your parents that are involved in real estate. And one of the problems was that, well, one of the ways that exhibited itself is that a lot of airlines went under. Yeah. If you notice, old movies from the late 90s, if you're watching them, you'll see them flying on airplanes, and you'll see Continental, you'll see U.S. Airways, you'll see all these airlines that no longer exist. And I think this is one of the problems, right? This was a big increase in a time where I don't think we necessarily needed that much of an increase in our airports.
I agree.
We built a whole bunch of houses, too, in this same time period that ended up being lost. But anyway, just kind of, it's something to think about. What do the numbers tell us?
Percentages. And how much something's changed over time.
It's something to think about in every scenario, not this particular scenario. What are the numbers telling you about what's going on? Culturally, what's going on. It kind of might give us those types of things. All right, here's another example. Something else to kind of talk about and think about. Find the percent of change. The number of taxi cabs in the U.S. in 2001. Oh, by the way, we forgot something in that previous slide. What did I forget?
You forgot to
Increase it.
I forgot to specify that this was a 30.95% increase. Okay, that's an important part of your answer. If you leave that off of your answer, you're going to lose points in a quiz or a test. All right, now back to this one. Find the percent of change again. The number of taxi cabs in the U.S. in 2001 was 31,800. All right, the number of taxi cabs in the U.S. in 2002 was 30,800. Interesting, right? 31,800 to 30,800. All right, so the percent of change is the amount of change, which we can just do that straight up, Kenny. There's 1,000. And the original amount was 31,800 times 100 to change it to a percent. 3.14% decrease. Now, is that a big decrease? Not a big decrease. What do you think might have caused this? Not Uber. Uber wasn't around yet. Now, the number of taxi cabs around now is just gone, right? It's kind of, I bet it's half of what it was 10 years ago because of Uber, all right? But 3.14% decrease, what could account for this 3.14% decrease?
People were really bad driving.
Economy.
Well, it was like around 9/11.
You could start
felt like less safe.
When was 9/11?
2001.
2001. What did people stop doing for about a year after 9/11?
traveling.
Flying. Okay. Where do most taxi cabs go to and from? Airports. All right. So there was a significant decrease. There was a significant decrease in people flying. More people drove to their destinations. More people rented cars. Fewer people take taxi cabs. And so it kind of caused a big decrease. Now, incidentally, if you wanted to do some interesting research, the number of people killed in 9/11 in the planes and in the buildings total was less than the increase of automobile accidents in the following year was people stopped flying and started driving. So more people, the increase in traffic fatalities in 2002 was more than the number of people killed in 9/11.
Maybe we should stop running.
Maybe we should not be motivated by our fears,
No, we should
right?
ride horses.
Yes,
When they
should all
count people
die.
that died 9/11, they count the cars that crashed.
yes, they
Oh
do.
my gosh.
All right, now here we go. A markup or discount. And again, it's not a bad question, but we don't need the conversation following it. All right, a markup results when something is increased or something is applied to a cost. Okay, taxes is a perfect example of markup. Now, this markup is going to be a percent of the original price. Okay? A discount results when a percent of decrease is applied to something, and that is going to always be a percent of the original price. So keep that in mind. You're always going to be, and I make this emphasis every year, and I need to because people still don't do it. They're always going to be taking a percentage of something, which means we're always going to be multiplying our percent by something. Okay, so markup is an increase. A discount is going to be a decrease that is applied to a cost. All right, so let's just look at some simple problems that involve this. A music store marks up the price of CDs they purchase at $9. They mark it up by 70%. Now there's two questions here, and if you're not careful, you'll miss one of these questions on the test. What is the markup and the new price? Okay, the markup is $6.30, right? The markup is 70% of $9. 70% of $9 is $6.30. So that's the markup, right? Got to be careful. We're answering the question that is being asked. $6.30 is the markup. I might ask you a question. What is the markup? Don't give me the price of the item. Give me the actual markup amount. All right. Now the new price would be $9 plus the markup, $6.30, which is $15.30.
$9 is
Not they used to be, really high. It was an expensive medium.
That's a
Yes. No. All right. Next example. A bookstore is having a 40% off all items. What is the discount? All right. Two questions here. Two questions. What is the discount? Go. The discount and the new price. All right, so it's asking, yeah, he's moving really fast, isn't he? Yeah. All right, the discount and the new price. The discount is 40% of, now you guys, it's really dangerous that you can do these problems in your head. Because what happens when you run across one that you can't, right? All right, so the process is important. The discount is 40% of $12. All right, and if you did the math there, that would be $4.80. Okay, now the new price, the discount price is another way to ask for that. The discounted price is going to be $12 minus the discount amount. 12 minus 480 is $7.20. So $4.80 is the discount. And then $7.20 is the new price, or we could call it the discounted price. All right. And I'm just kind of getting you used to how these questions can be asked for on tests. What is the discount? That's the actual amount that's being subtracted. The discounted price is the result of subtracting that price. All right. I think there's one more. In 2006, the 100-mile Beads Walkathon for Education Advancement, Development, and Success. Yeah. I'm not sure why it is.
I think it's supposed to be better.
Is it better? Education, Advancement, Development, and Success. Raised $36,000 for girls in Africa. The organizers hope to raise $100,000 in 2007. What will be the percent of increase in the amount raised?
So it'd be like X.
All right, so it'll be the amount of increase. All right, this is asking for the percent of increase, so let's go to our formula. It's the amount of increase over the original amount times 100. All right, so what is the amount of increase? If we want to go from 36,000 to 100,000. 64,000 over 36,000 is the original amount, and 64 divided by 36.
1.7
1.7 repeating.
7.
Okay, so 17 point, let's say 78%. No, that's not right.
It's 170.
It's 177.8. You said 1.7?
Yeah.
Okay. Yeah. Well, it's my fault. I didn't think it through. So 177.8% increase. All right. That is a lot of increase, right? We need to double it. It's almost doubled twice, right? Double and doubled again.
No.
Karis, what you got?
If you put like the 7 with the little repeating thingy.
Yeah, that's okay. That'd be a little bit more exact. And, sometimes it's important it's not sometimes, it's always important to include decimal places. Like you'd never want to do that to 178%. Unless it told you to round to the nearest whole percentage, never do that. When you get into geometry next year and you're going to be calculating angles and areas and volumes, always use more decimal places than you need. All right, if this problem told us that we wanted to have accuracy, or if a problem tells you want accuracy to the 10th place, then in the problem you need to keep at least 3 decimal places so that you can make sure you're accurate to the tenths. Because if you round in the tenths in your problem, you're rounding, and then you round again at the end, you're probably not going to be accurate to the 10th place. All right, and you could be talking about a percentage of a very, very large number. Right? So there's a lot of difference between 177% of $2 million and 177.7% of $2 million. There's a lot of dollar differences there. So keeping decimal places is going to make a difference. All right, here's your homework for this lesson.